So I picked this topic, like I was just saying, I picked this topic because I didn't get any particularly, you know, big suggestions from anybody on something they wanted to cover on this particular Data Friday, and I didn't have any special guest speakers picked out, so nobody was really planning on presenting. And this is something that I am very familiar with because most of my career has been involved in doing integrations at one point or another between systems or companies. So talking about middleware software and any sort of like queuing or architecture type stuff is really in my wheelhouse. And it's the kind of thing that you don't have to be an expert in it, or even somebody who uses it in order to like get the benefit of understanding why and how we use some of this stuff. So I'm going to pull up just some random charts around ESBs, which is an enterprise service bus, and some of these infrastructure concepts to kind of help illustrate why we would ever use them. And the first thing to understand is just any sort of integration you're doing between two systems, whether they're internally inside of a company or externally outside of a company. It's usually just so that you can exchange data and information between the systems. So you always have to decide which one is the master and has the authority and has the final say if there's any sort of disparity between the systems. And you have to also decide what the flow of information is going to be from system A to system B. So for most clinical trial systems, it's the source system, and so like Radar Station, the server side, ends up being the master of all the data. And if there's any conflicts, that's where it's resolved at, and then the data is then pushed out to any systems that it integrates with from there. So that's the first thing you got to decide is what direction is the data going to be flowing through, and you can see that in this little chart here with the little arrows. And then where is it going to flow to, right? So this would be all the other systems that it's integrating with. And then how is it going to get there? You can connect any two systems to each other, assuming they share a common language, a common protocol. You can connect any two of them. And you would do that by pushing an arrow straight from like the portal to the B2B interactions or the SOAPs request service, right? And that's called a point-to-point integration. And it basically consists of the same way you connect to a website on the internet. You give it a host address and a port, and then it sends it over the internet and it connects, and they just talk directly to each other and they pass data back and forth. And it's got advantages, right? The advantages of a point-to-point integration is that it's really, really easy to set up. You literally just give it an address and tell it to start sending messages, and then it gets going. The downside of that kind of integration is that if one of those systems goes down or doesn't have a queuing, software on its end, then you can lose information. You can lose messages. You can lose data. And then they get out of sync, and then there's all this back and forth trying to get them back into sync. There's a whole lot of work with that kind of thing. But the biggest thing is just like the availability of the systems. There's, can cause a lot of problems, and you can mitigate that kind of stuff with basic load balancing software or clustering software that, you have multiple servers handling the traffic from whatever is sending it to them. And then, you set up two servers on both sides with load balancers. And when they talk to each other, it's actually a group of servers talking to another group of servers. But that's not what an enterprise service bus is, right? Load balancers are really more just like traffic lights and traffic cops. And, they kind of divvy work up between various workers. So they don't serve the same purpose as an enterprise service bus. So like this is a load balancer. You can see there's a bunch of clients, there's a bunch of servers, there's a load balancer in between them that kind of like acts as a traffic cop and directs the messaging to whatever server can kind of do that work. So that helps with your availability, but it doesn't help you with, what if you have a bunch of different, I'll go back to my other one where the ESB was on here. What if you have a bunch of different types of systems and a bunch of different types of servers, all that need the same information? That's where an ESB comes in. And the ESB ends up adding a layer that is a consistent structure for messaging across various platforms. So rather than having to like an electronic medical records system, right? Some radiologist might do a radiology scan and get an image, and he needs to get that information over to the patient, we'll say. A point-to-point integration would be like he just sends that message over to the patient. Well, the problem is that there's a bunch of other departments that need that exact same information. And so he can do an integration with each department individually and send each of them the message, including the billing department and the ICU maybe, and he can individually send that message to every single one of them via point-to-point integrations, or he can just send it to the ESB, the enterprise service bus, that keeps track of every single time radiology does an image, where all does it need to go? The billing department needs to know so that they can make sure that they bill the patient properly. The patient needs a copy of it for his records. The other physicians in the ICU might need it for reference, on and on and on. But there's a whole list of people that need that same exact message. And what'll happen is they scan the image, they send it off to the ESB queue, and then that system, the ESB, forwards it on to everybody that needs it. They kind of copy it and do all your copies for you and then kind of send it over. And that's the primary purpose of an ESB, is to maintain the list of every single time I have this kind of information, where does it go? And there's other advantages too, right? It has queuing software in it. So it adds a layer of buffer, essentially, to all the downstream systems that it integrates with as well. So if for whatever reason, let's say they don't have load balancing and they don't have high availability on their system, it's just sit in a queue that's going to get sent to them for quite a while, potentially, until they're up and available. And then the ESB can send it over to them and confirm it's been sent. So the ESB software, when you hear about like TIBCO or which is what we use, it's a very common ESB software, or like Mirth, which is like an HL7 imaging middleware, or any number of any other middleware. There's thousands of them. Many of them very industry specific. Anytime you hear about them, their general purpose is to provide this layer of abstraction so that anybody who has something to say doesn't have to keep track of every single person that needs that message, or have to worry about whether or not their message actually got out, because they send it to the ESB stores it until it sends it into everybody who's supposed to get it, and keeps track of who has gotten it and who hasn't gotten it. It's like a mail delivery service, sort of. So it's got a lot of power for integrations, particularly around any sort of data intensive or real-time integration services. So when you need immediate quick delivery, an ESB comes in really handy. A lot of, with our sponsor integrations or our clinical trial integrations, when we're doing just transfers of a data file, what we'll do is a point-to-point integration with an SFTP server. And a lot of times we have a piece of software that's automated that, extracts the file, and then, it has a user ID and a login, and it remotely logs into whatever system the client has asked us to put the file on, and then we deposit the file there. And we have a relatively large team that manages that process to make sure that those files are delivered, manually monitors a lot of that. And an ESB actually serves the purpose of automating a lot of that functionality to confirm that it's sent, received, and if necessary, can do retransmits. So there's a lot of huge benefits to having a piece of software like TIBCO to kind of manage a lot of that work. TIBCO is usually used for like real-time integration. So like web transaction, I have one image, I need it sent, it needs to go immediately. The client needs it in real time. Hospitals in particular, they need the information immediately if there's a patient coming. There can't be this, oh, well, we get a delivery once a day of a data file. No, I mean, the patient might be up here in 15 minutes. We need his file now, right? And if the emergency room just did a scan and they uploaded that to the system, it needs to be available on my side within 10, 15 minutes. So it's a real-time integration that gets sent pretty quickly in that kind of case. And that's where these ESBs really shine. For like a daily transfer or a weekly transfer of data where it's like, we only do analysis once a month, try to get it to us every day so that we can do integrity checking and quality checks. It's not quite as important to have this ESB layer. And, the way you kind of determine whether or not, you need an ESB layer or you need a point-to-point transfer, a lot of times boils down to the frequency, the consistency, and the availability and the time-sensitive nature of this kind of stuff. So you have to assess the business requirements of the specific integration you're doing to make the decision of, is it worth the extra couple $1 million for an ESB? Or can I get away with paying someone an hourly rate to manually transfer it because the business requirements are lower? Once a day is fine. We'll have a person do it. So it gets into a lot of business questions of when does this make sense and when does it not make sense. And you got to use the right tool for the right job is really all it boils down to. Does it all make sense so far? Any questions from anyone? All right, I'll just keep on rolling then. So ESBs are incredibly powerful tool. It's one of those things that is a huge, automation effort. Like you can use something like TIBCO to automate daily file transfers, but it's kind of like using a nuclear bomb to kill an anthill kind of thing. A daily file transfer is, you download it and you log into your SFTP site and you post the file. It's not that big of a deal. When you're dealing with a system like a radiology system with like Mirth, where you have tens of thousands of radiologists all doing, scans that have to be sent over to hospitals, and then there's billing systems, involved, then it starts to make a lot more sense to involve an ESB system like Mirth, because there's literally, hundreds of thousands of integration points that have to be tracked and managed and maintained. And these ESB systems are backed by a database that literally is a database of just all the integration points, the servers, your requirements, the mappings between those 2 points. And then also it even goes another layer below that where it could do transformations as well. So what we commonly call like post-processor work, where we modify data after it's collected to fit a format or a structure that's necessary for a client system. An ESB like TIBCO or Mirth can do those transformations automatically at the message level on a specific thing. So if you're a radiologist and you do a scan and you sent it over to a specific to your queue, your ESB, that ESB may actually integrate with 2 different billing systems. One that is a vendor related system and one that's related to patient, billing. And those two separate billing systems, even though they basically do the same things, may actually require the message and the information on that specific piece of, data to be different. So they might want the date format in a different structure, which I'll just stay with that example because it's easy to understand. Sometimes some systems want it, year, month, day. Some systems want month, day, year. And some of them want a 4-year format, and some of them want a 2-year format. So TIBCO, rather than the radiology system having to keep track of every single different format change or every single different slight modification on the data that needs to be done in order for that integration to be maintained, you do it at the ESB level so that it can be tracked there and consistent. And the other thing that's cool about that is that format is structured based on the receiving side, right? So once you establish the format for the receiving side in the ESB, you just have to map to their format one time per sending system. So you essentially are consolidating all of your transformation and all of your, integration points one time into one layer. If you were to remove, let's imagine for a second on this picture that every single one of these systems needs to integrate with every single other one of those systems. And this becomes a really difficult math problem from a lift perspective for a data engineer. If for each one of these systems, you now have to do essentially a data transformation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times for every single one, right? So we have 12 systems here. They all have to do 11 transformations from what they send to what the receiving system is getting. Now you're talking about, was it 144 roughly integrations? And that's a lot of code. Now let's look how, the magnitude of development work associated with doing it to an ESB. You have one map to the ESB, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You only have to do it one time per system that integrates with the ESB. And so you basically have if you do a point-to-point integrations, what is considered a non-scalable solution to integration, where every single time you add a new system or a new client, you now have to multiply that client times the number of systems that they're receiving data from. And it gets really messy really quickly. Whereas on an ESB, you have this kind of buffer layer that adds all this other value. But the biggest value is just the fact that you don't have to do all these point-to-point integrations. You just got to map to the ESB. And you call it a day. I'm done. You want to add one more system? Fine. One data engineering problem mapping from that source system to the ESB. And then any of these other guys that want to do an integration with that system need to do a mapping from the ESB to them, but it's a one-time deal. And then if anybody else wants to use that same format or structure, they can integrate with them as well. So you get a multiplier effect by going to this ESB where it's a code reuse for transformation, right? And that's really the value of these ESBs. If you go to a sales pitch for these groups, like anybody who's selling this kind of software, they talk about that a little bit. And that's geared mostly towards people who don't understand how ESBs are. If they know they're selling to a fairly technical organization or a technical group that has used ESBs in the past, they start talking about the features of their specific middleware, which sometimes they get pretty ridiculous and not really useful, to be honest with you. Like, oh, you can have SQL code embedded into your transformation to do, like, no, man. I don't want SQL code in my ESB. But they all basically are the same. Some of them are specialized in one specific message type or industry, but They're all basically the same. TIBCO is one that's written, I want to say it's an Oracle product, but I could be wrong. But it's basically a high level ESB and middleware product that you can use it for anything. It can do anything, any type of messaging between any two type of systems. And these really high level ones are like that. But it is more work to configure it when you get into a specific industry and a specific use case, right? So while TIBCO could be used for medical billing, you wouldn't necessarily want to use it for medical billing because you would have to write all those custom objects, data objects within the ESB before it would be usable for that. Whereas if you just buy a medical middleware product like, that's HL7 compliant, which is a protocol, then they already have those billing objects already created for you. It's like having the default template already in there for you. So then you might have to tweak a little bit based on your specific implementation, but 90% of the work is probably already going to be done for you. So why are there so many? It's because every single one of them has like created a very specific industry that they are like, catering to and trying to make their lives a little bit easier. Eventually, what's going to end up happening is it'll all slowly consolidate over time. And you see that like, there's modules per industry for some of these higher level companies now. Like I'm sure Oracle has modules specific to medical billing by now. I haven't looked into it, but sure they do. And things like TIBCO and all these, they basically take software as an import to do the data engineering work at the ESB level. How do we leverage it at Signet? We basically do it for real-time integrations, and that's about it. It's overkill for a lot of our other stuff. We don't do a full data abstraction layer in there, is my understanding. At least when I've tried to leverage it for that, they just weren't ready for it. And I think that that's pretty common, actually. And when you start getting into platform level analysis and like you start getting into more of the data science, data analysis type work, ESBs are not good for that anyways. It's not a database for analysis. It's a database for operational processing, right? It takes a message in, it delivers it, and it moves on. If there's transformation code required in order to do the delivery, it will execute that transformation code. It's not good for storing data. Unfortunately, a lot of enterprises actually do use it for storing data, which is a huge no-no, but it's not meant for that, right? I worked at a company that essentially used it as a secondary backup for message storage. So if a downstream system had an outage, they would resend every message from the queue down to that system, which is cumbersome to say the least. Effective, but it's kind of like hammer and nail kind of thing where when you got a hammer, everything looks like a nail. So they used it for everything. I will say that team was really good at doing integrations though. They could fire up an integration with a new client in about 2 weeks because they had it down to a science. They were like, give me this, 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 and this. Here's the transfer specification. If you don't get it to us, you don't get done. And it was literally that simple to them. You either had the information we required or you didn't. But they were also, the negotiation power there was a little bit different in the fact that they weren't really integrating with clients per se. They were integrating with companies they had purchased. And they essentially would just lay down the law and say, listen, if you want to get your payout for your sale, you have to complete the integration. And this is what you have to do to complete the integration. So there was a huge motivation and sense of ownership on the side of the people you were integrating with. When you're dealing with clients, sometimes integrations take a little bit longer because there's a little bit of like a, hey, you work for me, man, attitude that you get sometimes. And it slows the process down because you gotta not piss the client off, right? But it slows things down. So these things can go really quick once they're really well defined and you have really clear roles and responsibilities defined and then your data objects are defined and your transforms are defined. They can go really, really quickly. Yeah, they save a lot of time and effort. Any questions? I'd like to use our ESB here more at some point.
So if the ESB is, presuming one of the things you're thinking about using it is moving data from all of our different systems into the data warehouse, is potentially like more fluid.
Yeah. I mean, the data warehouse would be just one more system to integrate with. And it's, the warehouse is really just a storage, analysis, and monitoring, like infrastructure is all it really is. And ESB is way more than that. It is used for basically anything that needs to talk to each other. If you put it through an ESB, you're starting to create a catalog of source systems in an ESB that if you bring a new system online, you can say to yourself, you know what I really need? I need data from the data warehouse. I need this data set from the data warehouse. Oh, look, there's already an integration point in the ESB. I can just pull it from there. And the data warehouse is oblivious that you're even necessarily using it in that way because it doesn't matter. In the same way, you could look at it and say, you know what I really need is I need to get data out to all these systems. I don't know who all is going to use it, but I'll publish it to the ESB as part of the catalog. And then anybody that needs this message can subscribe to that. It's almost like a broadcasting system catalog.
Can you get all of the HR systems talking to each other through one?
You can integrate every system to each other. Yeah. It really is. If you're leveraging an ESB properly, it becomes the hub of everything in the company if you're doing it properly. Yeah. And you should be able to, if you're passing it through and, like the HR systems are a perfect example actually, because there are so many other systems that want the data and the information in the HR system. And for the guys who run the HR system to try to keep track of who all needs to get notified every single time somebody is hired is just unmanageable. I'm sure that group is just like drowning in requests for sync information. If it was integrated into an ESB and then all the systems that are dependent on it, like Active Directory for user access control and role management, the portal for activation, deactivation of accounts. I'm sure there's LogMeIn software that's like remote virtual desktop software that could be tied into it. All those things have their own account management systems that have to keep kept in sync with HR. And ideally what you would do is set them up as just subscribers to the queue, the notification queue for the HR system that says this account's been deactivated. And so HR, you would deactivate it in the source system, which would be PeopleSoft or whatever it is we're using now. And then it would go into the queue out in the ESB. And then every other system on this list would say, oh, look, there's a deactivation message out there for HR. I got to disable this account, and it would just flow through. Does that make sense?
Yeah, much.
It makes
easier
a lot
than
of
whatever
sense.
they're doing.
Well, that's, I see
not everything's SSO, but the ones that are SSO is probably easier, but there's so many SSO different systems that you want to plug in.
Yeah, SSO is sort of like in principle the same kind of idea, right? They're trying to create a master system that has all of the authentication and role-based management in one location. But the problem is that if you set it up as a point-to-point integration per system, then you basically have to configure and set up SSL on every single like final destination system, right? And then if one of those systems has an upgrade or an update, then you break the SSO potentially for that system. And it becomes the problem of the SSO administrators to try to figure out how to fix whatever system is broken now, right? When you map to an ESB, what ends up happening is you're like, listen, this ESB object has every piece of data you could possibly ever need related to this SSO object of activation or deactivation. If your side of the system is not working, you need to troubleshoot your system to leverage and use this object properly, because you're clearly not using it properly, because we know it's right, because every other system in our network is working perfectly fine right now. So good luck. So it allows a certain amount of compartmentalization from a technical standpoint too, with the ownership of the systems and the teams. Once you have a published ESB object out there and message for the other systems to consume, there's a certain amount of like, I know my stuff works, everyone else is fine, this is on your side. So it allows a little bit of a segregation of troubleshooting and analysis as well. They're really cool, is really all I'm trying to get at, when used properly.
So Keith, this is Will. So as it relates to like the blinded data analytics product that the data science team works on, and we're beginning to receive more and more third-party data, right? We're receiving data from PPD, data from Icon, data from Clinical Inc. Now we're starting to talk about looking at some QIs for audio and video data. Where would something like this fit in, kind of in that process flow, or doesn't it?
In that process flow, we would define our transfer specifications or our data object specifications for integration with us. We would publish it to the ESB, and then anybody who wanted to flow data into the clinical data pipeline would meet that specification and would just flow in. And then BDA or any of the analytics data sets that we use for that would be built on top of what flows in.
Mm-hmm.
But it acts as kind of a gateway to, enforce standards, essentially, for the integration is another benefit.
Okay.
Well, the way we're doing it right now with these integrations is a little too customer friendly, honestly. Like, we kind of take a stance of like, anything you got, any data you got, we'll analyze it for you and we'll help you build out a better product and a better analysis for, risk-based monitoring or whatever.
Right.
Give us what you have and we'll work with it. Rather than from a SaaS model, from a software as a service model, you build what kind of analysis you do and then you publish what you're capable of doing it on. And from a business perspective, you want to have a mix, right? But you want to be leaned very heavily towards the SaaS model, not the custom model.
Mm-hmm.
As a general rule, Bracket was very much custom, do whatever you guys want kind of attitude, and that gets you a lot of business because you never say no to anybody. But the downside is it doesn't scale particularly well. So the more you want to scale, the more you have to start leaning more and more into this SaaS. Here's my standard. Please meet the standard, and then we'll get you something immediately. And that's where these ESBs come in, and like data warehouse comes in, things like that.
Right. All right. Thank you.
Okay, Keith, this is Danielle. I also have a couple of, please dumb it down a little bit for me. I think this is super interesting. But when you talk about the ESB, right, that we put on top of the clinical data pipeline, for example, would you then have one ESB for the company, or would you still be able to customize that for, say, a group of customers?
You can still customize it for a group.
Okay.
So it allows different levels of complexity. So you would publish your default, this is our standard integration, format and structure. Here's our default data transfer specification, right? And that you would publish as a company, right? And then when you deal with individual clients, if there's enough money on the table, then you do customization, you create a custom integration for them. And usually what ends up happening is they send you exactly kind of what we're doing now, whatever it is they have, and then you map it to your ESB model that you have. And what it does is it saves you all that work of, there's still the huge benefit of saving you all the work of having to map that one client's custom thing to your 50 systems that use that data. You just map it to your ESB and then it goes out to the 50 systems. It's one integration instead of 50, right?
Yeah. And then, thank you for that. And then conceptually, right, can I, sort of think that this ESB is like an RPA for data distribution?
Yeah,
Okay.
yeah, basically.
Okay.
Yeah, I mean, it basically ends up acting kind of like a a subscriber broadcasting system for data,
Yeah.
and it's all, they all have access control layer implementations on all of them, and there's login credentials associated, and systems can only pull the messages from the queues that they're granted access to, if that makes sense.
Yeah.
So like, just because the HR system is integrated into the ESB, and the web portal is integrated into the ESB, does not mean that the web portal can pull information out of the HR system.
Yeah.
It can only pull data and messages from the queues that the HR system has made available to the web portal. And it's really fascinating looking at the configuration of these things when you get into the console for like Mirth, right? It's literally tens of thousands of rows of point-to-point integrations and queue definitions that say, okay, this guy sends me messages, I drop it in this queue, and then anybody who wants to pick that message up that has the access rights of HR queue can pick it up off of that HR queue.
So it runs continuously. It's like real
Runs
time.
continuously.
Yeah.
It is a real-time system.
Okay.
Yeah.
Thank you.
Yeah. It's basically defines a ton of.
So I will have a stupid question. It's Alan. We have TIBCO, right? Or we.
Yeah.
So are we planning to integrate it with the CDP and or not?
Yeah, at some point, I think it's probably in the cards at some point. I think that's basically what we're looking for trial manager to CDP integration. We'll probably leverage TIBCO for that. Primarily, what it was brought in house to do was some of like the instrument monitoring integration stuff, so like Actigraph and some of those other things. And we've done it for some of the client integrations as well.
Okay, thanks, Keith.
I think we did an integration with Icon as well. So it was originally brought in for those purposes, but now that we have it, man, let's pop the hood on this thing. And we bought a Ferrari, let's race it.
So how difficult would that be? Like, are we talking months? Are we talking weeks?
I mean, it's really more a matter of prioritization.
Right.
It's a prioritization question. I think their standard timeline for TIBCO integration here, I think, is 8 weeks.
Okay, thanks.
Yeah. Like I said, I've seen it vary dramatically based on organization and who the clients are. Just like every other integration, right? It's just like the DCF process. If there's a party that you're waiting on, like there's nothing you can do, right? If they don't send you the data, you can't do anything. If they don't have the right format, or you're trying to send something to their system that they can't accept, then, or they don't even know what they want, that's a big problem a lot of times. They don't really know what data they need to do solve whatever problem it is they're trying to solve. With most of our pharmaceutical clients, it's pretty straightforward. We've collected data for clinical trials and they want their data. But when you start talking about integrating like an HR system and an accounting system, what all do you need? Do they need the roles and responsibilities of each individual person? And does the HR system need their bill rates? Maybe. What are you going to use it for? So the questions start to pile up pretty quickly when you do integrations. So cool, data infrastructure. Like I said, this is the kind of stuff I can talk about excessively.
And very passionately.
Yeah, I love it. I love it. Yeah, I love it.
Thank you, Keith.
Yeah. Anybody else have any questions or comments or other data problems I want to talk about? Okay. So yeah, ESBs, middleware software, very important conceptually. scaling. Yeah, hopefully we'll get more and more into this the farther we go in this company. So, all right, thanks guys. I guess I'll call it if nobody has any other comments.
Thanks, Keith.
Thanks for joining, guys.
Thank you.
Bye.
Thank you. Bye bye.
Have a good weekend.
Bye.
You too.
Bye bye.